In the typical North American math textbook, you will find a lot of review. Now, we will, of course, naturally then start grade 10 math with a little bit of review. So, writing linear equations. What are linear equations? Well, linear, so straight line. And equations that describe a straight line are, well, linear equations. So, in terms of vocabulary, the most common form that you usually see is slope-intercept form, or slope y-intercept if you prefer. Now, this is y equals mx plus b, or ax plus b, or whatever. Here, m, or a if you prefer, is the slope, and b is the y-intercept. Why? Well, let's think about this. Where the y-axis and x-axis meet, well, here x is 0. So if the line at x equals 0 has a particular value, that value is entirely from this term. So the y-intercept. Here, y value is b. And the slope is defined as rise over run. M equals, rise is the change in y, so y2 minus y1 over x2 minus x1. Now wait a second, what if it happens that we're going from x1 y1 to x2 y2, except down? Well, we find that the vertical y2 minus y1 would be negative, and the horizontal would also be negative, so the slope still comes out as positive. So, which way you do it between the 2 points doesn't matter. Now, the standard form is written this way: ax plus by plus c equals 0. Most people prefer slope y-intercept, except when they really don't like fractions. Because sometimes you get, well, fractions for the m and b values. This, by definition in standard form, a, b, c should all be integers. So whole numbers, be they positive or negative. We do point out that standard form is a little bit easier to enter into most computers compared to slope y-intercept, where you might have to use some sort of formula function on your word processor. However, well, given the frequency of use, really the slope-intercept form is more common. So why the standard form is not that? Well, who cares, really? But let's do some examples. So the equation of a line in slope-intercept form was a given slope and y-intercept. Then write the equation in the standard form. So we know that under y equals mx, or ax, plus b, this is slope, and this is y-intercept. Now, if they give us a slope and y-intercept, we just substitute in, right? Slope, 3x, and then plus negative 2. So we just put minus 2. You could choose to put it with plus bracket negative 2 and then simplify to this, but most people don't bother for hopefully obvious reasons. And then slope negative 1, y-intercept 5, y equals negative 1, we omit the 1, negative x plus 5. Now, slope negative 5 and y-intercept negative 3. would be y equals slope multiplied by x, and then plus y-intercept, which is minus 3 here. So here we have y equals 2x plus 1.5. Decimals, fractions, and so on are all acceptable when you're using slope y-intercept form, which is why it's so much more convenient than standard form when you are doing this by pencil. On the other hand, when you're inputting this into a computer, well, it's a little bit hard to input fractions into most computers compared to the amount of effort most people are willing to put up with, which is kind of sad, but hey. So we write an equation in slope-intercept form for each graph shown. Each grid on the first graph is 2 units. Each grid on the second graph is 1 unit. Well, if they don't give you a particular scale, such as, say, 5, 10, so on, then if the question tells you that each grid is how much, label it right away. Otherwise, you may usually presume that, well, each grid is 1 unit. If they don't tell you and there's no scale labeled. And of course, writing down the note that I presume is 1 unit is good if you're going to make any assumptions. So, y, x. When you draw graphs, you should label your axes. Although here we all know the convention, so sometimes you see them unlabeled. Alright. So, origin, 0, 0. And each grid is 2 units. So 2, 4, 8, and 10, 12. 12, why not? So 4, 8, 12, 16. And we need to find line 5 for slope-intercept form. So we look at the slope of line 5. So for every 2 units across, it goes 4 units up. Or rather, for every 1 grid across, it goes 2 grids up. Why are we counting grids instead of actually doing the units? It's because they happen to line up conveniently enough. And besides, as long as the units for the horizontal and vertical axes, the scales are the same, i.e. it's not like, oh, 1,000, 1. Well, as long as the scales match up, you can just look at the grids. On the other hand, to start with, you should work with the raw numbers, which are a safer method. So, 4 is rise, and run is 2. Rise over run is 2. The slope is 2, and the y-intercept is 2. So, line 5, m equals 4 over 2. It's pretty easy to eyeball given it lines up with all these intersections perfectly. And b equals 2. So y equals 2x plus 2. Line 6, L6, that's through the origin. The slope is, well, technically taking a bigger sample is better, but we see pretty clearly that it's just for every 2 units across, it goes 1 unit up. So m equals 2 over 4, and b, simplification here is actually optional, but, well, if the question gives you enough room, do it properly. If not, you can go across, even though that's not proper notation, really. B equals 0, so y equals 1/2 x. Line 7. Well, looking at line 7, we have a negative slope. So the bigger the x value gets, the smaller the y value. That's a negative slope there, in linear equations at least. So, For every 2 units, oh, that's not perfectly lined up. Wait a second. For every 3 grids, it goes down 4 grids. Okay. That means the rise is -4 grids, run is 3 grids, and since the scales are the same, well, that works out. If the scales weren't the same, we just calculate, oh, look, 16 to 8. That is 8. And, well, -8. And across we have 6. So, m equals -8 over 6, and b equals 16. And thus we have y equals -4/3 x plus 16. Alright, so the next one we have to do is on a different graph. We have to check to see if the scale is the same, and lo and behold, it is not. It is, each grid is 1 unit, which by the way is the standard convention if it's not labeled. And assuming there's no other information you're provided with that suggests it's something very, very different. X, so 2, 2, 4, 4, -2, -4, -2, -4, and 0 in the middle. So line 8. Well, we can pretty clearly see that it crosses the y-axis at -4. And here, well, it goes down 4 grids. For every grid it goes across. So in this case, because the scales are the same, that's -4 over 1. So m equals -4 over 1, which is -4. And b equals -4. So y equals -4x minus 4. And line 9. Well, here we have a positive slope, first of all. And then we notice that, oh, for every 4 units it goes across, it goes 1 unit up. So m equals 1 unit over 4 units. And b equals 3. So y equals 1 over 4, x plus 3. Line 10. Well, it goes through the origin, so that's a y-intercept of 0. And m equals, let's see. Well, it seems to be right on the intersection here and here. So that means for 3 grids across, 2 grids down. So rise is -2, run is 3, and b equals 0. Y equals -2/3 x and plus 0, which we don't bother writing. Alright, so let's do a few more examples. Write each equation in standard form. Now, we know that standard form is ax plus by plus c equals 0. Now, a, b, and c are all integers. There is, well, in some places there is a convention that a should begin as positive. In other places, they really could not care less, which is great. Why? Because here, we can just move this right over, which means, oh look, -3x plus 4y plus 4 equals 0. Of course, if your teacher wants a to be greater than or equal to 0, then of course this would be (3x minus 4y minus 4 equals 0 instead. So you multiplied everything by -1. You flip the signs to be shorter. Now, I do realize that in Canadian texts, and even in US texts, in North American texts in general, they have a strange tendency to be like, oh, +4, +4. This is a very interesting way to think instead of just moving it over. Fortunately, in some texts, this is not the case. They just say, oh, move it and change the sign. The same thing is, well, the result, but here we have 4x minus 3 equals -3y. Now, do we have a c term? No, but c can be 0. A or b can also be 0. So, really, if you have 0x plus 0y plus 0 equals 0, then that is really not a equation for a straight line, because it tells you absolutely nothing. Why? Think about this for a second. Whatever x is and whatever y is, that still holds true. So that's like two-dimensional space, period. XY plane. Anywhere on the XY plane, if you have 0, 0, and 0 for the three coefficients, well, that applies. So 4x equals -3y. That means 4x plus 3y equals 0, because we move this over. And there's no c term. C equals 0 here. So any of these, or any two of these for that matter, can be equal to 0 as the case requires. But not all three. That's not exactly an equation anymore. It would be just 0 equals 0. So 5x equals 3y minus 6. This would be 5x. And then what happens when we move this over? Minus 3y plus 6 equals 0. You might be thinking, hey, why didn't you line up these equal signs? It's because sometimes when you do a problem, the position of the problem on the page is not a place where you can line up the equal signs without risking running over the edge of the page. Hence, teachers are mostly not exactly picky about what happens if you do the problem starting right with the problem and then move the equal sign. However, thereafter, you should always make sure that your equal signs line up, because it just makes the question look tidier and easier to follow, which is very beneficial when your teachers want to figure out how you got this right answer, or where you went wrong and how many part marks they can give you. If your question is all over the place and you got the final answer wrong, or you got it right but the teacher thinks you might have cheated, well, that is not good, of course. Well, okay, so that's it for this initial review section, and we will continue on drawing more linear equations and writing more linear equations in the next review section.